So we're going to start the conic sections, and we're going to start with circles. So a circle by definition is the set of all points on a plane that are a given distance, okay, from a given point called the center. Now that given distance is your radius, all right? So basically if we look at this picture here, this image, we have the center here at the origin. We have moved out whatever this radius count is, it's 10 in this case. And basically every single point on this circle is 10 units away from that center. Now, when we talk about the circle and the points on the circle, it's just the points that are on the dark black. The red center is what we use to draw the circle, but it's not actually one of the points that would make the circle true or make the equation be true. Now, circles have a couple of different ways to write the equation. My favorite way is what's called standard form. And standard form is x minus h squared plus y minus k squared is equal to r squared. Now, things to know about this. This h value that is attached to x is the x value of the center. The k value that is attached to y is the k value of the center. But I'm going to zoom in so you guys can really see this. Notice that this says x minus h, but only h is the value for the center. Y minus k, and only k is the value for the center. So just be careful with the signs. And while the standard form says this is equal to r squared, r itself, just r, okay, r is the radius. So now we have that fixed point, we have that given radius, and we can draw a circle. So first problem here, we are given an equation in standard form and we are asked to graph it. So I highly recommend taking a second here and identifying your center and your radius. So the number that's attached to x right now, it says -3. So we're going to go ahead and flip that sign. So I'm going to go ahead and say it's 3. And what number is attached to y? That's -2. So flip that sign, and that's going to become 2. So our center is 3, 2. And remember, this is equal to r squared. So if r squared is equal to 16, that means r is 4, right? Take the square root of both sides. Now, any of you sitting out here saying, well, wait a minute, when you take the square root, you're supposed to put a plus minus there. You are 100% correct. But because your radius is a given distance, and distance must be positive, we can go ahead and just use the principal square root, which is the positive value of 4. All right. So now that we know our center and our radius, we can actually graph it. All right. So I'm going to go ahead and on my graph, I'm going to find my center of 3, 2. 1, 2, 3, 1, 2. Go ahead and mark it. And then I'm going to count left, right, up, and down 4 units from that center to show me where the edges of my circle are. So 1, 2, 3, 4 to the right, 1, 2, 3, 4 up, 2, 3, 4 to the left, and 4 down. Now, I am going to attempt to freehand this, and we'll see. Nope. Notability is trying to help me, but let's see if I can make this work. Now I'm hoping that Notability will eventually snap the circle for me if I hold it. Whoa, that is so not even close to a circle. Let's try that again. I was hoping it would snap a circle for me and just create it, but I'm going to go ahead and just, we're going to go ahead and with that squished thing that I just drew. Yeah, let's go with it. So obviously when you're trying to freehand draw a circle, there are some issues there. If your circle looks like you've attempted a circle, it's all good. If somehow your circle turns into a 6-pointed star, try and redraw it. If you're supposed to be drawing a circle and you end up drawing a triangle, yes, I'm going to critique that, okay? So try for your best. All right. All right, I'm going to just go ahead and slide over to number 2 here. And conveniently, our circle is again written in standard form, which I like. So let's go ahead and pull the center. So I'm going to take whatever is attached to x, change its sign. So this is going to be -1. What's attached to y, change its sign, +4. And my radius here, this is r squared. So r itself, or my radius, would just be 5. So let's go ahead and count that one. So -1, 1, 2, 3, 4. Let's count 5 in all directions. 1, 2, 3, 4, 5. 4, 5. I believe I've counted that out right. And we'll see what I can do here to make some kind of, wow, that just looks awful. So let's try this again. I do slightly better if I work in sections here. We'll go with that and call it good enough. All right, so that's what happens for a circle if it's in standard form. Unfortunately, not all circles come in standard form. There is also something called general form. All right. And please make sure you know the difference between the two formats, because I may ask you questions where I ask you about standard form and I may ask you questions about general form. Now, if you are given a problem in general form, you need to convert to standard form. And the way you're going to do that is by completing the square. And that's going to happen for both x and y. So in Unit 2, we talked about completing the square as a way to solve quadratic equations. It's not my favorite way to solve quadratic equations, but I wanted you guys to get the experience of working with it so that now when we need to use it to convert to standard form, we can. Now, there are some directions on this note sheet that I'm not a huge fan of, so I'm actually going to cheat just a little bit here, and I am going to just obliterate these directions here. Basically, the directions talk you through how to complete the square. And instead of using those directions, I'm going to go ahead and talk you through it. Okay? So the first thing we're going to do is I want to group together the x terms. So I've got x squared and I've got plus 2x. I'm going to leave myself a little space here, and I'm going to group together my y terms. All right, so y squared plus 6y, leave a little space here. And then this constant of 15 or -15, I'm going to move to the right side to get it out of the way. And when it moves to the right side, it becomes positive. Now, I need to complete the square for x, so let's do that. To complete the square, remember, you're going to take your b value, which in this case is 2, chop it in half, and square it. So 2 chopped in half is 1, 1 squared is, I'm going to add 1 here. Now, if I add 1 to complete the square for x, I need to come over to the right side and also add 1, so plus 1. Now I'm going to complete the square for the y terms. So I'm going to take my middle term here, my b value for the y variable, and I'm going to chop it in half. So 6 chopped in half is 3. Square that value, 3 squared is 9. So I'm going to add 9 to complete the square for y. So now, using just the x terms here, I want to factor that. So x squared plus 2x plus 1 factors into x plus 1 squared. I'm going to do the same thing for my y terms here. So y plus 6y plus 9, or y squared plus 6y plus 9 factors into y plus 3 squared. Okay. There's a plus sign between these. And then the right side is, what is that, 25? Yeah, 15 plus 1 is, 25. All right, so now that it's in standard form, we can do exactly what we've been doing in the last couple of problems. Identify your center, identify your radius, and graph it. So the center here is going to be -1, -3. So center is -1, -3. This equation is equal to 25, so I'm going to go ahead and say that's r squared, which makes my r value 5. I'm going to slide over here because I no longer need that equation. I just want the center and the radius. So center is -1, -3. Go ahead and plot that point, and then you're going to count out 5 left, right, up, and down so that you can find those boundary values. All right, let's see, 4, 5. That should be 5 there. All right. Let's see here. All right, not perfect, but it'll work for us. All right. All right, I'm going to go ahead and close the video here for this one, and then I will pop up a second video for the second page of this note sheet. As always, if you have any questions or concerns, send me a message in Canvas or directly email me.